Right. Hope you can hear me. Let's start the class. Uh, okay. Now, today I'll be more focusing on chemical calculation questions. So, uh, I'll be doing some new questions. So, therefore, you have to write down the questions and try them out. Then, after that, I'll be explaining the questions. I will give you some time as well. So, let's take down the first question. First one, write this question. First question. Total mass of total mass of total mass of equimass or equivalent mass equimass CH4 CO2 and C2H6 mixture is capital M. Is capital M. Derive an expression for total number of carbon moles in the sample. Carbon is 12, oxygen is 16, hydrogen is 1. Right, I will give you some time and try this on, then we can discuss. Total mass of equimass. Equimass means the, the mass of each component is equal. CH4, CO2 and C2H6 mixture is capital M. Derive an expression for total number of carbon moles in the sample. Right. So we can discuss this one. I will give you around 3 to 5 minutes. So, Right. So we have a sample. Sample we have CH4 and we have carbon dioxide and we have C2H6. So this is equimass. Equimass means the mass is equal of each component. So total mass is capital M. So therefore we can say this is M divided by 3. This is also M divided by 3. This is also M divided by 3. So the process would be, we will be calculating the moles of each and every component. Then based on that, we can calculate the moles of carbon atoms in each and every component and add them up. You will have the total number of carbon atom moles. That is the process. So we will calculate the moles of each component. In order to do that, you need to have the molar mass of each component. It can be done at the beginning of the question, or it can be done while you are doing the calculation as well. That's okay, right? So we can write the statements like this in CH4. This means the moles of CH4. This notation, everybody identifies this notation as moles of CH4. That's okay. In the sample, so you can say MCH4 divided by molecular mass of CH4. So this is M divided by 3. Then molecular mass of CH4, carbon is 12, hydrogen is 4, 12 plus 4, that is 16. Then in 1 moles of CH4, there is 1 mole of carbon atom. I told you in the class and as well as yesterday class as well, the bridge of the components or bridge of the compound is in terms of the moles. So you take like 1 mole of CH4, it has 1 mole of carbon, 1 mole of hydrogen atom. Sorry, 4 moles of hydrogen atom. So that is how the bridge or each and every component, each and every element is connected together in a compound. Or compound itself also connected together based on the number of moles. So the moles is the bridging item, not the mass, right? So you are going across equation, you are going across kind of a formula that is in terms of moles, not in terms of mass, right? So therefore, in carbon, in CH4, that is all the same thing because that is 1:1 ratio. And then in the same manner, we can calculate in carbon dioxide in the sample. So we can say this is first equation. This is M carbon dioxide, molecular mass of carbon dioxide. So you can say this is M divided by 3. M divided by 3. Carbon dioxide, carbon is 12, oxygen is 16, 16, 16, 32, 32 plus 12, 44. So this is the total number of carbon dioxide moles. So therefore, in carbon dioxide, you can say M divided by 3 into 44. Then in the same manner, since the screen is not enough, I will take take here. You write it down accurately. So I will take it here. NC2H6 in sample, NC2H6 divided by molecular mass of C2H6. So this is M divided by 3 into C2H6, carbon 24, 24 plus 6, that is 30. Right. So this is, so therefore, in carbon, in sample, or in C2H6, One mole is having two carbon atoms in C2H6 because C2, right? So this has to be multiplied by 2. That means 2m divided by 3 into 30. I'm converting this one into m divided by 3 into 15. So total number of moles I can take as, therefore, NC total is equal to m divided by 3 into 16. These are very simple things actually. 3 into 44 plus m divided by 3 into 15. You can arrange this one. M divided by 3 can be taken out. 1 divided by 16 plus 1 divided by 44 plus 1 divided by 15. So this is moles. So in this manner, you can calculate total number of moles, right? M divided by 3, that is 1 divided by 16 plus 1 divided by 44 plus 1 divided by 15. So you can do the calculation like in this way, right? I hope there are no questions on this one. I just followed the theories. If there are any questions, you can unmute and ask, or like you can ask from the chat window. Yeah. Next question. Next one. Do you need time to write this down, or else we can move on? Okay, I will give you some time. Since you have been asked about an expression, no need to take the final answer of this fraction summation. That's okay. Take. Actually, this is an MCQ question that I gave you. This is asked in I can't remember the year. I think like 1995 or something, but it's still valid. This expression was given, so you have to find the answer accurately. All right. Second question, number 2. You have to think a little bit on this one. A little bit of science or all level science is needed for this question, right? Write down this question. Density of water is 1 grams per cubic centimeter. Is 1 grams per cubic centimeter. We know this one. This is coming from physics. Calculate number of H2O moles in 1 liter of water sample of water. Give it a try. Then we can discuss. Okay, let's discuss this one. Density of water is 1 grams per cubic centimeter. Now listen very carefully on this logic, okay? Now, which means like in 1 cubic centimeter of water, the mass is 1 gram. So we have to assume that this is 100% pure water. So you take like 1 cubic centimeter of water sample, 100% mass is because of the water sample or water molecules. That is the idea of the purity, right? So if you have been given the purity component as well, like let's say like 98% of pure water. So which means like if you take 1 cubic centimeters of water, 1 gram into 0.98, only there will be water because the purity percentage will be there. Now here we have to assume 100% purity. ඒ වගේ කරුණොත් දෙනවා. මම ඒක මෙතනට ඇඩ් කරේ නෑ. මොකද මේක පළවෙනි ගාන නිසා. Purity component I haven't add. අපි ඉස්සරහට ඒවයි ගණන් හදනවා. හරිද? දැන් මේවා මේ එක එක ගණන් එක එක විදිහේ ගණන්. Right? So we have to understand how to do them. මේවා මේ එක එක මේ ගාන හදන්න මේ විදිහටයි කියලා ඔලුවට දාගන්න එපා. ලොජික් එක ඔලුවට දාගන්න. Right? So in 1 cubic centimeters of water, the mass is 1 gram. But we are talking about 1 liter. Right? So the unit conversion is very important here. First, I will tell you the unit conversion. 1 cubic centimeter is equal to 1 milliliter. Right? Then 1 milliliter is equal to 1,000 milliliters is equal to 1 liter. So which means in other words, 1,000 cubic centimeters is equal to 1 liter because of the first equation, right? Then 1,000 cubic centimeters, I can write it down like 10 cubic centimeters in, sorry, 10 centimeters into 10 centimeters into 10 centimeters. So this is 1 liter. 10 centimeter means 1 decimeter. You know, milli, semi, deci, right? Milli, semi, deci, milliliter, centimeter, sorry, millimeter, centimeter, and decimeter, right? 10 centimeters is equal to 1 decimeter. I hope that you have done this one in physics. 10 millimeters is equal to 1 centimeter, right? 10 centimeter is equal to 1 decimeter. 10 decimeter is equal to 1 meter. Okay. So in other words, you can say 100 centimeters equal to 1 meter. Make 1 meter. No? So this one can be rewritten as 1 decimeter into 1 decimeter into 1 decimeter, 1 liter. So this means 1 cubic decimeter is equal to 1 liter. These 2 points are highly important. 1 milliliter is equal to 1 cubic centimeter. 1 decimeter is equal to 1 liter. Or in other words, 1 liter is equal to 1,000 cubic centimeters. Now we are talking about 1 liter, right? So 1 liter means 1,000 cubic centimeters. So having said that, let's move into the question. So I can say mass of 1 cubic centimeter is equal to 1 gram. That is coming from the density, right? Then mass of this is actually water. Mass of water. Mass of water in 1 cubic centimeter. Mass of water in 1 liter means 1,000 cubic centimeters. This is the unit conversion. So that means 1 grams into 1,000, which is 1,000 grams or 1 kilograms. So we know the mass, right? We have been asked about the moles of H2O in 1000 grams. If you know the mass, you can calculate the number of moles by dividing it by the molecular mass. So we can say, therefore, NH2O is equal to MH2O divided by molecular mass of H2O. So you can say this is 1000 grams. Molecular mass of H2O is oxygen is 16, hydrogen is 1. 16 plus 2, 18, right? So this is 18 grams per mole. So you can say this is like simply 55.554 moles. So this is the NH2O in, or number of moles in H2O in 1 liter of sample, or water sample. Right? I haven't considered the purity component. I have taken purity as 100%, because if you have taken 1 gram, total of 1 gram is because of water. Right? So this is very simple, but you need this unit conversion as well to complete this question. 55.54 මං හිතන්නේ මේක මං ගත්තේ 1000 divided by 18 means 500 divided by 9, no? So that means 5 divided by 9 something, so that is 55.5555. So you can take like that, 5456. Okay, hope you have taken down this one. So we will move into the next question. Do I need to keep the screen more time? I don't know. Okay. Next question, number 3. Ilmenite. Ilmenite is a common mineral in Eastern Beach in Sri Lanka. %48 of ilmenite is consists of titanium dioxide, TiO2, titanium dioxide. Considering 100-gram sample of 100-gram sample of ilmenite. Calculate below. Calculate below. First part. Mass of titanium dioxide. number 2. Moles of titanium. Mass of titanium that can be extracted. Titanium 48, oxygen 16. Yeah, titanium 48, oxygen 16. Yeah. With this question. I will start the question. If you can continue the question. Going to continue answering. Now, mass of titanium, that is a straightforward one because mass percentage is given. So we can straight away say titanium dioxide mass in the sample because the mass percentage is given, right? There is I think correct. Yeah, these are correct. Good. Answers, I think correct, because I also don't have the answers here. I just at a glance, I think those are correct. I will tell you the process to do this one. So 100 grams into 48 grams, this is pretty straightforward. විභාගෙ ඇත්තට මේ වගේ දෙන්නේ නැහැ. මම මේ නිකන් ඔයාලට පුරුදු වෙන්න ඕන හින්දා මේ පොඩි පොඩි කොටස් හදලා දෙන්නේ. මේ ගාන ඇත්තටම තිබුණේ mass of titanium that can be extracted. This is an MCQ question, right? So the question was like, first statements are given, then considering 100 gram sample, calculate titanium mass or titanium mass that can be extracted. ඕක තමයි දීලා දුන්න ප්‍රශ්නේ. Right? This is an MCQ question. So this is the steps that you need to follow, right? So this is 48 grams. Then number 2, mass moles of titanium that has been asked. So you can say like number of moles, not mass, sorry, moles of titanium dioxide. Mass of titanium dioxide divided by molecular mass of titanium dioxide. So 48 grams divided by 48 plus 32. 48 plus 32 is 80, right? $80 grams per mole. Then moles of titanium, N titanium is equal to N titanium dioxide, right? මේකේ moles ගන්න වැරදි මට දාපු උත්තරේ. ඒක තමයි. Yes. මේක පාරම මම වැරදි කියලා. Right. So this is 48 grams divided by 80 grams per mole. So this can be simplified by 8, right? 8 means this is 6 divided by 10. 6 divided by 10 means that is 0.6 moles, right? Oxygen got that, වැරදි. You took only one oxygen. Okay.
Yes, sir.
Yeah, understood. You have to be careful. No? Then mass of titanium. So mass of titanium, like the moles of titanium is 0.6 moles, right? Because titanium dioxide has 1 moles of titanium. That is what I have done. So 48, I think 0.6 is correct. So mass of titanium would be, the moles is 0.6. The mass can be calculated by multiplying by molecular mass, right? So mass of titanium can be calculated N titanium into molecular mass of titanium. So this is 0.6 moles into 48 grams per mole. So make it 3 grams only that can be extracted in terms of grams. Titanium grams that can be extracted from ilmenite 100 gram sample. Right? So these are industrial questions actually, but you can do these. No need to know the process of the extraction. It's just a calculation. I hope this one, that yellow highlighted one in the screen, You understood this one. This is coming from titanium dioxide. 1 mole of titanium dioxide is having 1 mole of titanium. So that is the idea. And 1 mole of titanium dioxide is having 2 moles of oxygen. Okay. Right, let's move to the next question. Number 4. Calcium sulfate, and magnesium sulfate are mixed in 1:2 mass ratio. Mass of the sample is 2,562 grams. First question. Calculate total number of SO2 minus moles in the sample. Number 2. Calculate calcium mass and magnesium mass in the sample. All right. Here, calcium 40, magnesium 24, sulfur 32, oxygen 16. Right. I think you know the process, but I will also do this one. So the mass ratio is given. Some you have to read the question very carefully whether the mass ratio mole ratio is given. Sometimes they are giving the mass ratio, sometimes they are giving the mass mole ratio. So here the mass ratio is given. So the mass ratio you can from simple math you can calculate or you can convert them into a percentage very easily. Right? 1:2 means the 1 divided by 3 into 100% is calcium sulfate, and 2 divided by 3 into 100% is magnesium sulfate. So in that way, you can calculate the percentages of each and every component in this sample. There are only two. These questions are not having impurities, right? So these questions can be make complex by adding the impurities as well, right? So sometimes impurities also having magnesium or calcium or any other component which is we are interested. So impurity part still I haven't added them. අපි ටික ටික ගාන ටික කම්ප්ලෙක්ස් කරගන්නකොට ඒ ටික තේරුම් ගමු. Now uh, calculate the total number of sulfate moles in the sample. So before that we need to calculate the number of moles of calcium sulfate, number of moles of magnesium sulfate. Before that you need to calculate mass of calcium sulfate, mass of magnesium sulfate. So we can calculate calcium sulfate mass and we can calculate calcium sulfate moles, then sulfate moles. Magnesium sulfate moles, mass, magnesium sulfate moles, and magnesium or sulfate moles. So add these two together, then you will have the total number of sulfate moles in the sample. So this should be the process. So I will take calcium sulfate first. Mass of calcium sulfate is equal to 2562 into 1 divided by 3 grams. Then I can calculate moles of calcium sulfate, that is mass of calcium sulfate divided by molecular mass of calcium sulfate. These equations needs to be written, otherwise nobody will know which equation you have used. So therefore equations is a must, right? So this is 2562 divided by 3, this is grams, into molecular mass of calcium sulfate. Calcium is 40, sulfur is 32, oxygen 4 is 64. 6 136 grams per mole, right? Yes. Then therefore n sulfate moles. This is also the same because 1 moles of calcium sulfate is having 1 mole of magnesium sulfate ions as well. So this is 2562 divided by 3 into 136 moles. Then in the same manner, I can calculate mass of magnesium sulfate. This is 2562 into 2 divided by 3 grams. Moles of magnesium sulfate, that is mass of magnesium sulfate divided by molecular mass of magnesium sulfate. So this can be written down as 2562 into 2 grams divided by 3 into molecular mass of magnesium sulfate. Magnesium is 24, sulfur is 32, this is 64, 0, 120. 120 grams per mole. So you can say therefore NSO4 2 minus ions from magnesium sulfate is 2562 into 2 divided by 3 into 120 moles. So you can add these two. Therefore, total sulfate moles in sample 2562 divided by 3 into 136 plus 2562 into 2 divided by 3 into 120 moles. I'm not going to take the final answer. I think you can take them out, right? Make another may 2562 in divide by 3 can be taken out. Then you can do a simple math. May 10 dekedi make highlight don't do the math or don't do the calculation. Take it into the final section. Do the math there because otherwise it will be taking more time. So look at then the errors will also be minimum. Okay. Then the second part is we have been asked the calcium mass and magnesium mass in the sample. So we know calcium sulfate and magnesium sulfate moles. Yeah, so hence we can calculate calcium mass and calcium moles and magnesium moles, then calcium mass and magnesium mass as well, right? So you can take number 2 in calcium sulfate. We have already calculated this one. 2562 grams, sorry, this is moles now, divided by 3 into 136 moles. Therefore, N calcium 2 plus same 62 divided by 3 into 136 moles. Then mass of calcium 2 plus. Mass can be calculated by multiplying mole and molecular mass, right? So because N is equal to M divided by capital M, mass can be calculated N into molecular mass, right? I'm using the same equation. So mass can be calculated N into capital M. Right? So mass of calcium 2 plus will be 2562 divided by 3 into 136 into 40. So this is in terms of grams. Sorry to the so this is moles into 40 grams per mole. So you will have the answer in grams, right? So in the same manner, you can calculate mass of magnesium as well. So we know moles of magnesium sulfate is 2562 into 2 divided by 3 into 120 moles. Therefore, magnesium 2 plus moles, that will be 2562 into 2 divided by 3 into 120 moles. Therefore, mass of magnesium 2 plus is equal to 2562 into 2 divided by 3 into 120, 24. So this is in terms of grams. So I have, if you have noted, I have used the same molecular mass for magnesium and magnesium 2 plus. I think you can understand that one. For ions as well, you can use the same molecular mass because you are losing only 2 electrons in these cations. You know, electrons are making very minimum impact to the total mass of an atom. So therefore, you can take relative atomic mass as of an cation or an ion, both cations and anions, as the relative atomic mass of the respective neutral atom, right? So that's okay. You can take it like that. That is same for sulfate as well, right? So this is how you calculate the mass of each cation, calcium 2 plus and magnesium 2 plus. Make a මෙහෙම තියන්න එපා. Final answer you have to take. Okay. Right. The fifth question. මේක මොනවද ප්‍රශ්න තියෙනවද? Are there any questions on this one? Right. Fifth question. Okay. Good. Very good. So the fifth question. Write down 0.365 grams of HCl. 0.365 grams of HCl is mixed in 18 grams of water sample. Calculate total number of H moles in the final mixture. Hydrogen is 1, chlorine is 35.5, oxygen is 16. In the yesterday's class, final question is very important. That speed test number 7, the last week paper, I have asked to derive something. De Broglie wavelength is equal to h divided by root 2 kinetic energy into m. So go through the recording. That is important because that equation, the questions related to that equation has been asked two times in 2020 and 2024 MCQ questions. So derivation of that equation is quite important. I have discussed that one in the previous yesterday online class. Go through the recording. I have shared it in the group. If there are any questions, you can ask me during the class, our physical class. Right. Actually, this is a modified MCQ question. I have modified a little bit. This is asked in 2006 or 2007. Right. I have modified a little bit because you don't know one concept in the exact question. So therefore, I have modified a little bit here. So we are talking about a sample here, mixture. In mixture, we have HCl. We have added 0.365 grams, and we have water as well. Water 18 grams. 18 grams means, according to our calculations that has been learned today, the density of water is 1 grams per cubic centimeter. So we are talking about 18 milliliters of water. I think you can understand that part. Density of water is 1 grams per cubic centimeter. So 1 cubic centimeter mass is 1 gram. So 18 grams is, you are talking about 18 milliliter sample. We are mixing 0.365 grams of HCl. So we have been asked about the total number of hydrogen moles in the total mixture. So you need to understand at the end we have HCl and we have H2O also in the mixture. Both of them are there. Both of them are generating hydrogen atoms. So you can calculate, you have to calculate HCl moles that has been added and hydrogen moles coming from that HCl part. And H2O moles in the sample and hydrogen moles coming from that part. That is how you have to do it, right? So we can say added HCl moles. That is mass of HCl divided by molecular mass of HCl. This is 0.365 grams divided by 36.5 because chlorine is 35.5. This is 36.5. So this is grams per mole. So the answer is here 0.01 moles. So therefore, N hydrogen from HCl, that is 0.01 moles. And in the same manner, you can calculate added H2O moles. MH2O divided by molecular mass of H2O. So this is MH2O is 18 grams. Total molecular mass of H2O is also 18 grams. Yeah, per mole. So this is 1 mole. So therefore, N hydrogen from H2O is 2 moles, right? Total is 2 moles. Therefore, NH in total sample is equal to 0.01 plus 2 moles, that is 2.01 moles. 2 point zero 1 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 moles. 2 point z මේ කාණම නෙමෙයි මේ පොඩි වෙනසක් තියෙනවා කියලා mole fraction එක ගැන අහනවා. But this calculation is also needed for the total question. Is there a
So
question?
2.12 moles. ඒක වැරදිද?
2.12 moles. මේ 1 2 එක කොහෙන්ද ආවේ? 2 එක නම් එන එක තේරෙනවා. 2 එක
The
ආවේ
chlorine
hydrogen වලින්
35.5 ද 36.5 ද?
35.5.
ඒ ඉතින් මේ දීලා තින්නේ 0.365 වලින් 35.5 බෙදන්න.
නෑනේ දැන් HCl නේ එක.
ඔව්
HCl
සර්.
උනාම 36.5. අයි හයිඩ්‍රජන් වලින් එකක් දෙනවනේ. ක්ලෝරින් වල 35.5 plus
හරි.
1. හරිනේ. වරද්දන්න එපා ඉස්සෙල්ලත් ඔක්සිජන් එක කරලා තිබුණා. අපරාධ ඒ වගේ වැරදි කරන්න එපා ඈ. හිත කලබල වෙඩි. හරි ඊළඟ ගන්න. Next question. පමිතු හරිද මේ ගන්න. මුල් ප්‍රශ්න තියෙනවද මේ?
හරි සර්.
Good. Okay. Right. Next one. මේක යන්න ටිකක් අමුතු ගානක්. මම අර ගෙදරදී I think I have given you some questions in the as an homework. මම ඒක බලනවා මම Sunday මේ ගානත් ඒකට ඒ නෝට් එකටම ලියාගත්තත් කමක් නැහැ මේක නෝනේ. නැත්තම් ඔයාලා හදාගෙන එක ගත්තත් කමක් නැහැ. Butyric acid, butyric acid contains only carbon, hydrogen, and oxygen. A 4.24 milligram sample, make a note on that one. Milligram sample of butyric acid is completely burnt. It gives 8.45 milligrams of 8.45 milligrams of carbon dioxide and 3.46 milligrams of H2O. First part, what is the mass percentage of each element in butyric acid? Butyric acid කියන්නේ මොකක්ද කියලා දැනගන්න ඕනේ නැහැ. This is just for the calculation purposes. You finally you can take the formula, right? Second part, the molecular mass of butyric acid was determined by experiment to be 88 grams per mole. What is the molecular formula of the acid? So මේ ගාන I'm not going to do it now. මම හිතන්න ඕන මේක. හිතලා ඊට දැනෙනකොට හදාගෙන එන්න මම මේක කතා කරනවා. මේ වගේ ගණන් තමයි සාමාන්‍යයෙන් එන්නේ. අර අපි හදන ඉදීම ගන්නත් වෙනවා. This is something new that you have to think. Right? මේක හදාගෙන එන්න Sunday එනකොට. Right? So Sunday I will be doing MCQ, sorry, chemical kinetics and sorry, chemical calculations and chemical bonds. So don't miss the class, Sunday class. I think both of you haven't attended the previous class, yesterday class. Go through the recording. I have done some important questions on the recording as well. Go through the recording as well. Okay. So let's start the class from here for today. Thank you very much. Good night.